Hi everybody. Alright, well the next thing we have with linear is just, I wanted to do a lesson with linear applications. And you got your slope-intercept form. The slope, if you can find some sort of rate, if you can see the word per something else between two variables, that is a good indicator that you found the slope of the line. The y-intercept is the initial amount, and we use the variable b, and maybe b stands for beginning. I don't know. I should look that up sometime. And then an ordered pair, you have some relationship between the two variables. Like in 3 hours, we've driven 70 miles or something like that. The miles and hours relationship, that would be some sort of an ordered pair. Alright, so I just want to look at a couple of examples and then we will be finished with this. Okay. So example 1, an accounting firm determines that the value V in dollars of a copier T years after its purchase is given by negative 300 T plus 1,500. V is the value in dollars, T is the number of years. Interpret the y-intercept, and that's B, that's 1,500, and the slope, M, is negative 300. So we're interpreting this. 1,500 is the initial cost of the copier. The cost of the copier when it was new. Alright. And then the negative 300, the value of the copier depreciates, goes down $300 per year. So every year it's worth $300 less. So basically in 5 years it's worth nothing. And copiers at a school or something like that, chances are that's the case because they get used a lot. Alright, number 2. The sales for Foot Locker were approximately $6.5 billion in 2014 and $7.2 billion in 2014. Write a linear equation that gives the sales in terms of the year. Then predict the sales for 2021, assuming that the trend is fairly constant. All right. The ordered pair, 6.5 billion goes with 2013. I'm gonna set variables. Let's see. I'm gonna let the X equal the sales in billions of dollars. So we won't use all the digits because we are rounding. Let's say Y equals, I'm going to make it so we're not using 4-digit letters, years after, I think 2010 with this problem would be a good place to put Y. So our ordered pairs that we have, 6.5 billion goes with 2013. And the reason I'm going, when we talk about a rate, dollars per year, dollars would be the Y. Well, the dollars actually would be the x. And then, so I think I may want to switch that around. I think I want to make y, yeah, I want the sales to be the amount of dollars, and the x, sorry about that, I'm going to switch these two around. If I think dollars per year makes more sense. I'm thinking of slope here, not years per dollar. That doesn't make as much sense. Dollars per year, and usually we have the y values over the x values. So I think it makes sense to switch that around. Now the years after 210, so this is 2013. I'm putting 3 there, and then that was $6.5 billion. And the other ordered pair was 2014, so y or x is 4, and $7.2 billion for that year. Now the slope from these two ordered pairs, I'm going to take 7.2 minus 6.5 over 4 minus 3. So this is over 1, and that's 0.7, which is just simply 0.7. So about 7/10 of a billion, $700 million per year is what the increase is right now in this context. So in the y equals mx plus b, m is 0.7. X, I'm going to use the second ordered pair here. Doesn't matter. You can use the first. You're going to get the same answer for b, no matter what. So 7.2 equals 2.8 plus b, and I'll subtract 2.8, and that is what, 4.4 equals b. I got 4.4 equals b. So my final answer here is y equals m 0.7x plus 4.4 billion. Now, the next thing it was asked here is to predict the sales for 2021. 2021 implies that x equals 11. That's 11 years after 2010. So y equals 0.7 times 11 plus 4.4, which is 7.7 plus 4.4, 11, which is 12.1. So y is 12.1, which would be $12.1 billion. Okay. You guys take care now.